Hey there, StudyBuds! I'm your StudyBud Glenn and welcome back to our channel. For today's video, we are going to discuss the right triangle and its applications. Back from our first video, we have discussed that trigonometry is all about triangles, specifically those with one of the internal angles measuring 90 degrees. These triangles are called right triangles. Now, we will be talking about them again with today's discussion. First, recall the trigonometric ratios from our previous lesson. They are needed in solving problems involving right triangles. Let's dive into our first example. You are given this figure. In this figure, we need to solve for the height of the triangle. But before that, let's first determine the given. We have the hypotenuse, which measures 3 kilometers, and angle B, which measures 16.30 degrees. The height then is the opposite side. Recall that the sine of an angle equals the opposite side of that angle divided by the hypotenuse. Thus, our equation becomes the sine of 16.30 degrees equals the opposite divided by 3 kilometers. Manipulating the equation and using our calculators, we find that the opposite side equals 3 times the sine of 16.30 degrees is equal to 0.842. Thus, the height of the triangle is 0.842 kilometers. Now let's move to another example. We have here the triangle ABC, given that A equals 40 degrees and C equals 18. To solve for a triangle, we need to solve for the unknown angles and sides. In this case, we need to find the values of sides A and B and angle B. We no longer need to find the value of angle C since it is a right triangle. C equals 90 degrees. First, we identify that the opposite of the angle given is A and that the hypotenuse is 18. Hence, we can infer that the sine of 40 degrees equals A divided by 18 as defined by the sine ratio. By manipulating the equation, we get A equals 18 times the sine of 40 degrees, which is equal to 11.57. We now have found one missing part of the triangle. Let's proceed to finding another one, which is the length of the side B. From the diagram, side B is the adjacent side of the given angle. One trig ratio that utilizes the adjacent side directly is the cosine ratio. And we know that the cosine of an angle is simply the adjacent divided by the hypotenuse. We know that the hypotenuse is 18, so we can say that the cosine of 40 degrees equals B divided by 18. By manipulating the equation, we find that B equals 18 times cosine of 40 degrees, and that equals 213.78. We have solved B. We find the next and the last missing component of our triangle, which is the measure of angle B. We know that the sum of the internal angles of a triangle is equal to 180 degrees. Then we can say that A plus B plus C equals 180. We already know the two angles, 40 and 90, which adds up to 180 degrees. We can find B by subtracting 130 degrees from 180 degrees and find that B equals 50 degrees. So we have found all the unknowns in this triangle, which are side A, that is equal to 11.57, side B equaling 13.79, and angle B, which is 50 degrees. This is the process of solving a triangle. You need to find the values of all the missing components of a triangle using the given measures of other components. And we're down to our last topic, which is the angle of elevation and angle of depression. In surveying, the angle of elevation is the angle from the horizontal looking up to some object. Meanwhile, the angle of depression is the angle from the horizontal looking down to some object. Let's have some example. The angle of elevation of an aeroplane from John is 23 degrees. If the aeroplane's altitude is 2,500 meters, how far away is it from John? Let's first illustrate the problem. Let the distance between the plane and John be x. From the illustration, we find that the opposite side is 2,500 meters and the hypotenuse is x. We can solve x by using the sine ratio. Sine of 23 degrees equals 2,500 divided by x. Manipulating the equation, we find that x equals 2,500 divided by the sine of 23 degrees. We can use our calculator to solve this and find that x equals 6,400 meters. Now we can say that the airplane is 6,400 meters away from John. Let's solve for another example. This photo was taken from a point 500 meters horizontally from the Opera House, and we observe the waterline below the highest sail as having an angle of depression of 8 degrees. How high above sea level is the highest sail of the Opera House? We are given the angle, which is 8 degrees, and its adjacent side 500 meters, and we need to find the opposite side. This example is a simple tangent problem. Remember that the tangent of an angle equals to the side opposite to that angle divided by the one adjacent to it. So, the tangent of 8 degrees equals h divided by 500. Manipulating this, we find that h equals 500 times the tangent of 8 degrees. We can solve this using our calculators to find that h equals 70.27 meters. Through this, we can say that the height of the tallest point of the Opera House is approximately 70 meters. And we are done. Other problems similar to this might ask you for the values of other components. Just follow the process we've shown and identify which variable is which. We hope you find this lesson fun and exciting, StudyBuds. This has been your StudyBud Glenn, reminding you to study well. See you in our next lesson, StudyBuds.